Good morning, dear children. Yesterday we had seen Bronsted-Lowry acid and base. Then we have also seen about the Arrhenius concepts of acids and bases. And today it is Lewis concepts of acid and base. So what are Lewis acids? The acids are the substances which can accept an electron pair. Acids can accept electron pair. Now, one which is deficient of electron will accept the electron pair, and bases are donate the electron pair. Right, children? So this is the concept of Lewis acid and bases. What is there? Certain compounds like if we see the reaction between BF3 and NH3. BF3 NH3. So we know nitrogen, outermost orbit, 5 electrons. So 1, 2, suppose go to 3, hydrogen, hydrogen and hydrogen. So you see one lone pair of electron is left with it, whereas BF3. So B, fluorine, 1, 2, 3, 4, 5, 6 and 7 and one base boron. Again fluorine, 1, 2, 3, 4, 5, 6 and 7. 5, 6 and 7. So boron has 3 electrons in the outermost orbit. So this is the structure of BF3 NH3. But what we see, boron has not completed its octet. It is deficient of electron 2, 2, 4 and 2, 6. So what will happen? This nitrogen, this has extra lone pair of electron 2, 2, 4, 2, 6, 2, 8. So it has not participated in the bond formation. So it will donate this electron to B. This type of bond is also known as coordinate covalent bond. Okay, and in this case you see one which is donating the electron will known as base. Bases can donate the electron pair, so NH3 can be base, and BF3 is accepting that electron pair, so BF3 is acid. And also for your information, we have read also that it is known as coordinate covalent bond. The difference between Bronsted-Lowry acid and the Lewis acid is, in Lewis acid, acids do not have proton. Acids do not have proton. They are giving the electron pair to the another compound. Okay. Electron deficit species, like if you talk about, should I write here? Electron deficit species like AlCl3, cobalt 2 plus, magnesium 2 plus, they are acids. Okay. And what are bases? Bases are which can donate the electron pair. So H2O, if you remember the structure of H2O, oxygen has extra electron pairs. Okay, so 2 lone pairs are there. So H2O, comma, OH minus, comma, NH3. Right now I have shown you how NH3 can donate the electron pair. So these are known as Lewis bases. So this is the concept of Lewis acid and Lewis bases. Now we will come for the ionization constant of water and its ionic product. Ionization constant of water and its ionic product. Some substances like water, we see that water can behave both like acid and bases. Water can behave both as both like acids and bases. Yesterday we had seen 2 reactions. The first reaction was NH3 aqueous plus H2O liquid will give NH4 plus ion equals plus OH minus ion. This is also equals. So what we see here, this water is behaving like acid here. Why? Because it is losing the electron. Bronsted Lowry acid है, ठीक है. And another reaction which we see, that is HCl. Yesterday I had explained you in the Zoom class. HCl, that is aqueous, plus H2O, that is liquid, will form again hydronium ion and H3O plus, aqueous, and Cl minus, aqueous. Here what we see, this H2O is accepting the proton. When it is accepting the proton, it has become H3O plus. That means when it is accepting the proton, it is behaving like base. So we see that same H2O is behaving like acid here and behaving like base here. So this has the unique property of water. In the first case, it is donating the proton to ammonia, so it is acid. In the second case, it is accepting the proton from HCl, so it is behaving like base. Now now another term, that is acid and base. So इनका conjugate acid और base भी होगा. So we can equilibrium if it exists like H2O liquid plus H2O liquid. Here it is acid and here it is base. So what will happen? Conjugate acid and conjugate base will be prepared. So H3O plus aqueous, and it is conjugate acid plus OH minus aqueous, it is conjugate base, so dissociation constant can be written as dissociation constant is equal to K is equal to concentration of product, that is H3O plus OH minus, as we were doing earlier, divided by H2O. Left side में H2O only is there, so H2O concentration. Now denominator H2O can be cancelled. Why? Because water is a pure liquid. Water is a pure liquid. So concentration of H2O is not taken. Therefore, now it will be written as K is equal to H3O plus into OH minus. Now we know H3O plus hydronium ion can also be written as H plus ion concentration. In this case, it is known as ionic product of water, that is H plus ion concentration and OH minus ion concentration. The concentration of, अभी इस टर्म को क्या बोलेंगे बेटा? आयनिक प्रोडक्ट ऑफ वाटर, आयनिक प्रोडक्ट ऑफ वाटर, करेक्ट. अब कॉन्सेंट्रेशन ऑफ H प्लस आयन इज फाउंड, एक्सपेरिमेंट से क्या मिला? 1 इंटू 10⁻⁻⁷. सो experimental calculation say that H plus ion concentration at 298 Kelvin is 1 into 10⁻⁻⁷ molar, right? And dissociation of water produces equal amount of H plus and OH minus. So OH का भी यही concentration हो जाएगा, ठीक है. Therefore H plus ion concentration is equal to OH minus ion concentration, क्योंकि when water dissociates, one H plus and one OH minus is produced. So H plus is equal to this is equal to 1 into 10⁻⁻⁷ molar. So Kw is equal to H plus into OH minus. So it will be 1 into 10⁻⁷ into 1 into 10⁻⁻⁷ molar. So it will become -7 -7 -14. So 1 into 10⁻⁻14 m square, or we can also write it or 10⁻⁻14 m square. right? Now this value of Kw is dependent on temperature and why? Because we know it is a equilibrium constant, ionic product of water. ठीक है. And density of pure water is density of pure water is equal to, ये मालूम होना चाहिए, 1000 ग्राम पर लीटर. ओके. एंड मोलर मास वाटर का क्या होता है? सभी को पता है 18. मोलर मास ऑफ H2O is equal to 2 into 1 plus 16 is equal to 18 gram per mole. This we know. So these things we know. Now we have to find the concentration of molarity or concentration of H2O is equal to mass given, है ना, डिवाइडेड बाय क्या फॉर्मूला है मोलरिटी का? मास अपॉन वॉल्यूम इन लीटर इनटू मॉलिक्यूलर मास. दिस इज द फॉर्मूला ऑफ मोलरिटी. यू अंडरस्टूड चिल्ड्रन? फर्स्ट चैप्टर हमने पढ़ा था. तो मास अपॉन वॉल्यूम को डी कह सकते हैं, डेंसिटी. सो डेंसिटी मालूम है 1000, बिकॉज यहाँ जिसको नहीं समझ में आ रहा है उसके लिए, बिकॉज डी इज इक्वल टू एम अपॉन वी. सो डेंसिटी मालूम है, mass upon volume in liter upon molecular mass, it is 18. When you will divide this will give you 55.55 molar. That means molarity of pure water is 55.55 molar. So ratio of dissociated water अगर निकालना हो मुझे, तो dissociated water so that undissociated, तो dissociated versus ratio of डिसोसिएटेड, सॉरी ये ब्लर आ रहा है, एक मिनट. हाँ हाँ, रेशियो ऑफ डिसोसिएटेड अपॉन अनडिसोसिएटेड वाटर. डिसोसिएटेड वाटर, तो डिसोसिएटेड का लिया था हमने 10⁻⁻⁷ मोलरिटी डिवाइडेड बाय 55.55. सो व्हेन यू विल डिवाइड, ये भी नीचे आ जाएगा फिगर. सो 1.8 इंटू 10⁻⁹ और अप्रॉक्सीमेटली 2 इंटू 10⁻⁹. ठीक है. सो इक्विलिब्रियम, अब ये वैल्यू आ गई तो 2 इंटू 10⁻⁹, यानी इक्विलिब्रियम विल शिफ्ट टुवर्ड्स द अनडिसोसिएटेड वाटर. एसिडिक कब होगा? कोई भी सॉल्यूशन एसिडिक कब होता है? व्हेन HCO का कॉन्सेंट्रेशन, H3O हाइड्रोनियम H+ आयन कॉन्सेंट्रेशन इज मोर देन OH- कॉन्सेंट्रेशन. व्हेन इट इज न्यूट्रल, व्हेन बोथ विल बी इक्वल, H3O+ will be equal to OH- ion concentration. And when it will be basic, when H3O+ ion concentration will be smaller than OH- ion concentration. So I hope you understood this: acidic, neutral and basic, okay, and ionic product of water. Tomorrow I will tell you about pH scale.